This is the first lesson in week 2 of online learning, solving radical equations. A radical equation is just an equation with a radical expression in it. We're going to use properties of equality to solve the radical equations. So when you're solving the radical equation, you're just finding the value of an unknown. Usually it's finding the value of a variable, such as x. In order to solve for x, you need to isolate x on one side of the equation. In order to do that, you may use properties of equality. For example, you may add, subtract, multiply, or divide each side of the equation by a number in order to isolate x on one side of the equation. Number 2, we're going to identify extraneous roots when solving these radical equations. Sometimes when you solve a radical equation, the answer does not work in the original problem. If it doesn't work in the original problem, then it is not a solution to the original equation, and it's called an extraneous solution or an extraneous root. So in the warm-up, we have 4 simple examples of radical equations. Number 1, they say the square root of x equals 2. Well, we really don't have to do anything. We should know the square root of 4 is 2. But if you were solving this equation using your algebra properties of equality, you would undo the square root by raising each side to the power of 2. When you do that, when you square a square root, it undoes everything, and you get x equals 2 squared. So x equals 4. And then if you were going to formally check your answer, you would say the square root of 4 equals 2, and we know the square root of 4 is 2, and so the answer checks out, and that is a solution to the original problem. In number 2, it's a cube root of x equals negative 2. So to undo the cube root and just get plain old x, we would raise each side to the power of 3. And you get x equals negative 2 cubed. The reason I put negative 2 in parentheses is because when you're raising a negative number to a power, you want to put parentheses around it. It's good practice. When you enter it in the calculator, if you don't put parentheses around it, you will get an incorrect answer. So negative 2 to the power of 3 is negative 2 times negative 2 times negative 2. So you have x equals negative 8. To check your answer, you would take the cube root of negative 8 and see if it equals negative 2, and in fact it does, and x equals negative 8 is a solution. The third example is much like the first one. You would raise both sides to the power of 2, and you get x equals 3 squared, or x equals 9. To check your answer, you would substitute 9 for x, and you get the square root of 9 is 3, and it checks out, and x equals 9 is the solution. Number 4 is a little bit different in the fact that you have the square root is equal to a negative number. In this case, it's negative 2. When you see something like that, your answer is no solution. The principal square root is always a positive number. If it's ever set equal to a negative number, it is no solution. Any expression, the square root of anything, is always positive. So whenever you see a negative number on the other side of an equation with a square root, your answer is no solution. So in general, the first step is to isolate the term containing the unknown using algebra strategies. And the second step is to check answers and eliminate any extraneous solutions. In example 1, all they want to know is how are the equations A, B, and C different? When solving radical equations, you want to isolate the radical expression on one side of the equal sign. So in examples A and B, we would have to do a little bit more algebra in order to isolate the radical expression, because we'd have to remove, oops, I'm sorry, let me move that back. We'd have to move the 7 to the other side by subtracting 7 from both sides. And we'd have to divide both sides by 3 in order to get the square root of x isolated on one side of the equal sign. In example B, this 9 is, we would need to subtract 9 from both sides of the equation in order to isolate the radical expression. In letter C, the radical expression is all lone on one side of the equal sign, so you could simply square both sides or raise both sides to the power of 2, and you get x plus 1 equals 64. So x equals 63. And if you check your answer, you would say the square root of 63 plus 1 equals 8. The square root of 64 equals 8. And you know that's true. It checks out, and your answer is 63. So for A and B, we're going to do those kinds of examples in the next lesson. Now we're going to do 4 more examples. In letter D, the radical is isolated all by itself on one side of the equal sign, so you can raise both sides of the equation to the power of 2 to undo the square root. And you get 2x equals 3 squared. So 2x equals 9. And then if you divide both sides by 2, you get x equals 4.5. Then when you check your solution, you would say 2 times 4.5 equals 3. The square root of 9 equals 3. And we know the square root of 9 is 3. So your solution to the equation is x equals 4.5. In letter E, the radical expression is all by itself on one side of the equal sign. So I'm going to raise both sides to the power of 3. And you get 2x minus 3 equals 2 cubed. So 2x minus 3 equals 8. 2x, if I add 3 to both sides, I get 11. And if I divide by 2, I get 5.5. So I'm going to substitute 5.5 in for x to see if it is a solution. 2 times 5.5 minus 3 should equal 2. So I have the square root of 11 minus, the cube root of 11 minus 3 equals 2. So I have the cube root of 8 equals 2, and I know the cube root of 8 is 2. So x equals 5.5 is a solution. The third one, this one's a little different because x is being raised to the power of a rational number, x to the power of 1/3, which is the same thing as the cube root of x equal to 4. But let's say that you didn't remember that. And so I'm going to erase it. And you say, well, I can multiply or raise both sides to the power of 3. And when you raise a power to a power, you multiply the exponents, and you end up with x to the power of 1 equals 4 cubed. So x equals 64. When you raise 64 to the power of 1/3 in a calculator, you will get 4. So x equals 64 is a solution. The last example looks a little different, but the radical expression is still the only thing on that side, on one side of the equal sign. So you can square both sides of the equation, but you have to square the whole thing. So you end up with x minus 1 squared equals x plus 1. So the radical sign went away. But now we have a quadratic equation. When you're solving a quadratic equation, you have to set it equal to 0 in order to find the solutions. So the first thing we're going to do is expand the left side and then distribute. So x minus 1 times x minus 1 is x squared minus 2x plus 1, and that should equal x plus 1. In order to set the equation equal to 0, I'm going to subtract x from both sides and subtract 1 from both sides. So I get x squared minus 3x equal 0. Now that the quadratic equation is set equal to 0, I can factor it using the greatest common factor. So x times x minus 3 equals 0. Now I have the product of two expressions equal to 0. If the product of the two expressions is equal to 0, one of the expressions has to be equal to 0. So x equals 0 or x equals 3. Now you have to check your answers. So the first thing we're going to do is check for 0. If I substitute 0 in for x, I get 0 minus 1 equals the square root of 0 plus 1. And I get negative 1 equals the square root of 1. That is not possible. The square root of any number is positive, so that is not a solution. And x is 0 is not a solution. It's an extraneous root or an extraneous solution. Then we're going to check 3. We check 3. 3 minus 1 equals the square root of 3 plus 1. So you get 2 equals the square root of 4. And I know that the square root of 4 is 2. That checks out. So the answer to the problem, or the solution to the equation, is x equals 3. X equals 0 did not work in the original equation. It is an extraneous solution. It is not a solution to the original equation. The last example is an application problem. And it says, I'm just going to straighten this out a little bit. It says, in medicine, the body surface area is used to help determine the proper dosage of medications. And they give you a radical equation that models the relationship between the body surface area, a patient's weight, and the patient's height. So here's your radical equation. They want us to solve for h, so write the equation in terms of h, and then find the height of a patient who weighs 90 kilograms and has a BSA of 2.1. As you can see, I rewrote the equation. It's a little different from the other problems because it's going to involve one additional algebraic step in order to isolate the radical. And that is, we need to multiply both sides of the equation by 60 in order to get h by itself, or the radical expression by itself. So we're going to multiply this side by 60 and that side by 60. So when we do that, we get 60 times b equals the square root of w times h. Now I can raise both sides of the equation to a power of 2, and I get 60b quantity squared equals w times h. In order to solve for h, you divide both sides by w, and your equation is h equals 60b squared over w. And b is your BSA. So now I can plug in my 90 kilograms and the BSA of 2.1 in order to solve the problem. So height equals quantity 60 times 2.1 squared over w. So the height of this person is 176.4 centimeters. So here's a simple application problem of solving a radical equation. And that's it for today's lesson.